Hello, my name is Ryan Seco, and this is our Arduino powered conveyor belt. So a little run through the code. So here's all our global variables and setups for the libraries. So we had a library for the load cell for the HX711 amplifier for the load cell. We had to define the calibration factor for the load cell, and these are for the serial data output and the timing signal for the load sensor. And this is like the scale function, so we can operate the load cell. Our initial duty, K value, which we estimated using the IR sensor. Here's for the RGB, the pins. And in our setup, we have our PWM initial function. We configure the pins of port B as output. This sets the scale using the calibration factor, and the scale 1 tare, assuming there's no weight, it puts it at 0, and then we set all the pin modes as output. Then in our loop we have more variables, the potentiometer value, the sensor value, our duty max using the potential value, our R value, which is basically the distance that the package is going to be from the IR sensor, and these are max distances. And this is just 2 for loops to kind of get rid of like little error within the distances, because we weren't getting a steady distance. So this kind of gets us to the 1 R value. This is calling our myMotor function, which you'll see in a second. The first if is if the R value is greater than the minimum distance and is less than the max distance. If the load cell has a value reading over 1, which will represent a person standing on the load cell, the motor will move, and the RGB LED will shine blue. If there's no one on it, duty is 0, and the RGB will shine red. And then this is an else if statement, so even if there's no package in front of the IR sensor, the duty is 0 for any distance greater than R. If R is greater than Dmax or less than Dmin, and it shines red, and there's a little bit delay. Here's our PWM that we got from the lab. Our set PWM0 function, PWM1, which we didn't really use, and my motor function. So this if the duty is greater than 0, it'll run, I believe, in clockwise, and then if else, the motor doesn't move. And this is the function to change the color of the RGB LED. So onto the wiring. It's a little messy. So these are the amplifiers. How it's connected. So E plus is the first pin, and it's to 5 volts. These are to the load sensors, and then these are to 5 volts, the D out, the clock, and ground. The RGB is connected over here on this breadboard, so it's red, blue, green. We have resistors so we don't shorten the bulb. This potentiometer is used for the motor to vary the speed, and you can see we connected using the H bridge for the motor, and we use the motor, we connect it with this coupler, and then the RGB is attached right here. So now onto the corner.
Hi, my name is Leah Fiedler, and I'm going to give you a demonstration of how our prototype works. So as you can see, when this is all set up, even if there's no package on the conveyor belt, that means the motor's not running, the LED turns red, and even if someone is standing on the load cell, the motor doesn't move and the LED stays red. Now, if someone were to put a package onto the conveyor belt, it still doesn't move because the load cell isn't activated, so the LED is still red, and if you press on the load cell, the LED turns blue and it activates the conveyor belt.